work is calibrate. What the calibration is for is to make a transformation between what the camera sees in the camera window and to what the projector projects out. So that would make everything line up as far as like the projections. So to calibrate, I just used like that classic OpenCV Zhang calibration pattern.
Oh, the TV pattern.
So let's change it, whatever. So now that it's big enough, I just press space. Now it's calibrated. So during calibration, it just captures all the corners of all the checkerboard of the chess.
Checkerboard.
Yeah. And we use those as object points into a camera calibration, and then that way we can calibrate the camera. And then also we sort of, because like the media that you project out is rectangular, it's in pixel coordinates, and so once we project it out, we want to capture it in the image coordinates. So this kind of gives you the relationship between how the projector is going to project them and what they actually look like. So we kind of want to modify their coordinates by this transformation. So now when you bring this over there, so it's on, you should see just 5 blobs in here. So he's going to just straighten it out, and then once I press calibrate, now it begins tracking. So as he moves it around, the image follows the board. So basically what happens is the coordinates of these blobs are found. Then we kind of perspective warp the media to fit those blobs, and then we modify them again by that relationship that we found to project them out accurately.
Right. Yeah, I haven't seen a similar demo from you probably know Johnny Lee's work?
Yeah.
Yeah, similar idea, right?
Right. So he was basically doing
on the Wii. He did on the Wii.
Because both Wii remotes have infrared cameras built in.
Right.
So he's doing something very similar with these infrared blobs. It's kind of where the work that we were stemming from. But it's not very practical to have like these physical markers, and like they use batteries, and it's sensitive to infrared light from the outside. And once we saw that the Kinect came out, the Kinect gives you full 3D geometry of the entire space.
I see.
So this way, instead of kind of creating our own geometry by marking it off, we can use what the Kinect sees and detect objects within that.
I see. This is one step beyond the Wii then. So it's stay away from infrared.
Yeah, so we want to be able to stay away from this. So this is what we were doing up until the Kinect came out.
I see.
So let me show you.
It changed the game. The Kinect cover changed the game, isn't it?
Yeah.
It did change the game.
So we calibrate the Kinect in a similar way, because the Kinect has a RGB camera,
right?
640 by 480, and also has a depth as an infrared camera at 640 by 480, and it has a GPU on there that makes calculations based on because it actually has an infrared projector that projects out an array of dots. So depending on where these dots are, the distances between the dots, it can then figure out the depth of different objects in the space. So it gives you a 640 by 480 by 640 depth image. So within that, and there's been like some of the people that have been working on the Kinect lately have come up with different drivers for it. Because the Kinect is kind of closed source right now. So there is a driver that came out by the company that designed it. It's called OpenNI, but it's not really open. I don't know why they call it that.
But it's called Open.
Open and not.
Open or not. I see. Open or not. I see. Oh, NI?
Stands for Natural Interface.
I see.
And it basically gives you an API to interact with the Kinect skeleton. So once you stand, it can detect all your limbs and your hand positions, your head. But that driver doesn't provide us access to the regular camera on the Kinect. So there's a different driver that we have to use to get access to the RGB camera. So we use the RGB image to calibrate the same way we just did with the other version of this. It's just a little bit weird that this is the image that you have to project for it to be calibrated properly. So you can see that I'm changing the brightness and contrast of this until it sees the points. Oh, man. Can you turn off those lights? With the regular webcam, we have access to things like exposure and different camera settings. With the Kinect, we don't have access to
RGB. RGB don't have it.
Well, we do, but we don't have access to things like exposure and like aperture of the lens. And
So the API is not there.
Becomes, yeah, so it becomes more difficult to calibrate it and get it set up so it sees the checkerboard pattern. So to kind of mess with that. This is tough. Let me change the color of this slightly.
So you try to capture the calibration point.
Yeah, it needs to detect them, and it's kind of difficult with light.
So it had to make that curve, huh?
You're gonna see a bunch of Can you turn on one side?